Hi, welcome to the screencast for the Chapter 17 Partner Quiz. This is the key and the explanation for version 2, so feel free to look at version 1 also, even though they're very similar. So question number 1 asks, at 793 Kelvin, the equilibrium constant for reaction is 0.393. Do reactants or products dominate in this equilibrium? Explain how you decided. So when you look at this, the 793 temperature has to be given because equilibrium is temperature dependent, but it really isn't part of our decision. What we need to know is the equilibrium constant, 0.393, so KEQ is 0.393, and that's calculated by taking products over reactants. So if the number is less than 1, that means we have few products and lots of reactants. So that's letting me know that reactants are formed more or dominate, and the equilibrium lies far to the left for this equation. And the marks here are just reminding me of my mark scheme that this was worth 2 marks out of the 10 marks for this quiz. So then looking at number 2, people did pretty well on number 2. If you want to maximize the products of the following reaction, which concentrations would you lower? Well, anytime you want to maximize products, you either have to increase the reactants, the collisions, or decrease the collisions on the product side. So since I'm being told I have to lower something, that means I should be lowering either of my products, CO or H2O or both, would cause fewer collisions on the product side, which means there'd be more collisions on the reactant side and more product would form. Number 3, volume and pressure get a little tricky to think about, but it says for the following reaction, should you increase or decrease the volume if you want to increase your yield of product? So I want to increase the product and I have to change volume. So what I need to look at and see is which side is more crowded. If neither side is more crowded, then changing volume or changing pressure won't matter. But when I look, I have 2 moles on the reactant side, but I have 3 moles on the product side. So my product side is more crowded, which means increasing or decreasing volume is going to affect this side of the reaction more. So since it's the product side that's going to be affected more, I want to decrease the collisions on the product side to increase the amount of product made. So to decrease the amount of collisions, I should make it less crowded, which means I should increase the volume. So I would increase the volume, making both sides less crowded, but since the product side, remember this is like the school bus, the product side had more kids in each seat to begin with, so increasing the volume, taking some kids off the bus, making it less crowded is going to help the product side more. And that means then the collisions will occur more on the reactant side and form more product. And number 4, what effect would an increase in temperature have on this reaction? Which way does the equilibrium shift? Does product increase or decrease? In this case, they let you know heat is a product. So adding heat, increasing the temperature, is going to be like adding a product and will shift the equilibrium to the left. And that means product decreases. And the reason why is because the reaction is exothermic, so heat acts like a product, creates more collisions on the product side, and ultimately creates more reactant.